We're going to consider a case where we have just a resistor and a AC circuit. So there's a variable source of EMF that's going to vary sinusoidally applied to the resistor. You want to see what happens with just the resistor on its own. So the fundamental relationship that we're going to build off of is Ohm's law, that the voltage is equal to the current times the resistance. So the current's always just proportional to the voltage. So our time varying EMF is going to give us a voltage across the resistor, and we're picking this to be our reference for phase. It's going to be the amplitude of the EMF, and it's going to go as sine of the driving frequency times time. That's the angular driving frequency. So omega d is 2 pi times the frequency. All right. The current is in phase with the voltage, so it means that the current through the resistor is in phase with the voltage drop across the resistor. So the current as a function of time is just going to be the amplitude of the EMF divided by the resistance, and then this is also sine of the driving angular frequency times time. And this is the simplest case, is if I just have a resistor and an AC circuit. I'm going to make my plots and see what they look like for the case of just a resistor. So the voltage drop across the resistor is a function of time, and also plot a cycle for the current in our circuit as a function of time. So we pick this to be a sine wave, so it starts at 0 when t is equal to 0, and we just have a sine wave with an amplitude of the EMF, and the current is also just a sine wave. Where this amplitude is going to be the amplitude of the EMF divided by the resistance. If it is just a resistor and an AC circuit, we can look at the phasors. I'm going to have a phasor for the voltage, and so the length of that arrow is the amplitude of the voltage across the resistor. And then there's going to be a parallel phasor, because there's no phase offset for the current. And so there's the current amplitude, which would be the EMF over the resistance. If all we have is a resistor in our AC circuit, that's all there is. There will be a varying voltage, there will be a varying current, but the voltage and the current all change with the same phase. So these phasors are just going to rotate around counterclockwise.